Hello everyone. So next we will see that in what form the sequence can be given in the questions. Okay, so first is sometimes they will give you in this form 1 by 2, 1 by 3. That means every term of the sequence will be given, right? So they can ask you to write the nth term or the general term, nth term of the sequence, right? You will see some questions later. So that means here an is 1 upon n. So now you can verify because n belongs to natural number, so you can put it. So when you put 1, you will get the first term. When you put n equal to 2, you will get the second term. So okay, like that. So when you put n, you will get the nth term, right? So this is one kind of question they can ask. Second is they will give you the general term. Suppose minus 1 raised to power n. Okay, so they will ask you write the 10th term of the sequence, right? So 10th term will be put n equals to 10. So that means 1. So you can also write the 100th term of the sequence. So it would be what? Put n equals to 100, that means 1, right? So similarly they can ask you to write this term. So tell me what could be this, what value you will get when you put n equals to this or this, right? Just put n equals to this value and this value. You will get the corresponding value of the term, right? So these are the two way. Another definition now will, another way they can give you a sequence is in a recursive form. That means they will give you first term and for the rest of the terms they will give you a formula. Suppose like this one. Okay, so for n is greater than equals to 1. So that means when you put, so a1, so sequence, you can write a sequence in this form, right? But here you know only first term, and for the rest of the term you have given the formula. So in this place you have written 1, right? So in place of a2 they have given the formula. So put n equals to 1 here, you will get a2 equals to a1 plus 2. So a1 we know, a1 plus 2, so that means 3. So a2 will be 3. Now a3, again use this formula. So put n equals to 2 here, so you will have a2 plus 2. So that means a2 is 3 and 2. So that means your a3 will be 5, right? Similarly, can you write a4? Put n equals to 4 in using this formula. So you have to use this formula every time. So put n equals to 3. So you will have a3 plus 2. So a3 is 5. So 5 plus 2, that means 7. So now a4 is 7 and up to so on. So in this form, they can also give you a sequence, a recursive form, right? So you can have a question in this form as well, right? So next term we have is subsequence. So as the term suggests, subsequence, that means a part of a sequence. So sequence, you know, see, you in general you write a sequence in this form. The specialty of this thing is that the order 1 2, this is the natural order of the sequence, right? So subsequences, you just chose some part of these terms, right? You choose a1, a3, a5, a7. So let me just write it, a3, a5, a7. But the thing you must keep in mind is that this order should not be changed, right? So it should be in increasing order of the natural number. So 1 3 5 7. Okay, you can't write it like this, a1, a5, a3 and so on, right? So this is one subsequence. Other I can choose is a2 of even numbers, right? a6 and a8 up to so on, like this. It could be of prime numbers, so a2, a3, a5, a7 and so on. Okay, so infinite number of sequence you can make from this sequence an, right? So these are the subsequence of this sequence an. Okay, so if sequence is converging to some point L, okay, if you are able to prove that your sequence is tending to point L, that means your every subsequence, okay, every subsequence will tend to that point. Okay, so every subsequence will tend to that point. So this you can write it like this. And conversely, if you are able to prove that every subsequence of a sequence is tending to a fixed point L, then you will say your sequence is also tending to that point. Okay, so if you are able to prove that these two so these are the two subsequences, right? And what are the so here we introduce a new term, that means complementary subsequences. So when you call those two sequences as complementary subsequences, when they're subscript, okay, so n union n dash double dash, when they give you this capital N, then you will say these two sequences are, and the intersection of these two are non-empty. Okay, so when you a union, you take a union of all the subscript of n dash and n double dash, and they will give you a capital N. Okay, then you will say capital or n, yes, so you will say that your sequence, two sequences are complementary. Okay, you can also you have to check this thing also. Okay, so here the sequence of odd numbers and sequence of even numbers. Okay, so when you just take a union of n and n double dash, that means 1 3 5 7 up to so on, and 2 4 6 8 and up to so on. When you take a union of this, you will get a this thing, you 1 3 4 up to so on to natural number, right? All natural numbers, set of all natural numbers, right? So that means these two sequences, if I take a union, it will give me a original sequence, that means an. So whenever it is possible for the two sequences, you will call those sequences as a complementary sequences, right? So if your complementary sequences, suppose here they are tending to point L, and n2 is also tending to point L, this implies a and double dash, sorry, a n will also tend to point L. So this is another way to show that your sequence is tending to point L. If you are able to show that your two subsequence tending to point L, then your sequence will also tend to point L, right? So for example, suppose this is your sequence an. Okay, so you take a subsequence a 2n, that means this, and odd numbers 2n plus 1. So now when you draw it on a real line, you will see that your a2n is tending to 0. Okay, a2n plus 1 is also tending to 0. Okay, and 2n union 2n plus 1 give you the set of natural numbers, right? And there is nothing common in between them, right? So that means your two subsequences, and these two subsequences are complementary. When you just take a union of them, you will get original sequence, and your two subsequences are tending to 0 to the same point, right? So that means your an will also tend to the point 0, right? So this is the way to show that your sequence is also tending to the same point, right? And if you are able to get that your subsequence is tending to different points, suppose there is a sequence that a2n is tending, suppose okay, let's take another example. So it is minus 1 raised to power n, right? So a2n, if you talk about the term of if you take the even terms, you will get 1 1 1 1 and so on, right? And if you take the odd, you will have minus 1 minus 1 minus 1 minus 1, like this one. So that means your an is tending to 1, right? And a2n plus 1 is tending to minus 1. So both are tending to different points, right? So that means this implies that an is not tending to the point, or you can say your an is not convergent, right? So if it is convergent, you say that all the subsequences go to the same point. But if there exist two subsequences, right, which are tending to different points, so first is tending here, first is tending to 1, other tending to minus 1. So if you get any two sequences which are tending to different points, then you will not say that your sequence is convergent, or you will say your sequence is not convergent, right? So this is the way to show, right? So if you have any doubt, you can ask me in the comment section. Thank you very much.